Hey guys, what's going on? Welcome back to another video. It's Thursday. We're going to learn more about area of polygons. That was awkward. Yeah, polygons. We know the formula that we've been learning this week is the area is 1/2 perimeter times apothem. And hopefully if you haven't caught on by now, we're not usually going to give you the perimeter apothem. We're going to make you work for a little bit because life's like that sometimes. So this first question is a regular hexagon, and this one looks like we were pretty generous, right? We gave you the apothem, which is 26, and we can see that one of the sides is 30. So I think this is an easy one, right? If one of the sides is 30 and there are 6 of them, the perimeter part would be 30 times 6, and the apothem is 26. And if we crunch some numbers with our calculator, half of 30 times 6 times 26 is 2340. 2340 meters squared. All right, cool. That was an easy one. Let's take it a step further though. So this is the same hexagon as before, but what we've done is we've taken one of those little triangles and removed it. So I want to find the area of what's left over. There's a few different ways you could do this. Take a second and see if you can think of one. I'm going to eat this bugle, America's favorite finger hat. Did you figure it out? I hope so. So one way you could do this, I'll talk about both of the two ways I can think of, is you could take the area from the last one. Right, we know this is the whole thing. So I could do 2340 meters squared, and I could subtract off the area of one triangle. Right? Not too hard to find that area, because we know the height and we know the base of those triangles. So the area of one triangle would be 1/2 30 times 26. And that comes out to be 390. So if I did 2340 minus 390, that would work out to be 2340 minus 390 is 1950 meters squared. Okay, I can think of a different way you could do this too, though. Notice that if this is a regular hexagon, then all of these triangles are the same. Right? So we had 6 to begin with, and we took one out. So really, the area of this should just be 5/6 of the area before, the whole area. So the alternative way to do this is just to multiply 2340 by 5/6. And I'm going to double check here, make sure that I'm not messing anything up. But you can see that we get the same answer that way too. It's still 1950. Let me know if you think of a way that I didn't think of to find that. There might be some other crazy, obscure things that you could do. All right. They ask, what is the probability that you would hit a space on the shape without the triangle? So let's say like it's a dartboard, right? And you're throwing darts at this hexagon. And what's the probability that you hit a space that's not here, right? So I kind of use that up here to help us find it, right? It'd be 5 out of 6. There are 5 regular triangles and one that's dark. So the probability would be 5 out of 6 of hitting one without that triangle. And then the probability would be 1 out of 6 that you hit the missing triangle. All right, cool. Look at this beautiful graphic here. It says that we're planning on tiling our bathroom floor, and we need to cover 120 square feet with tiles. You find beautiful tiles that have a side length of 10 inches. Find the number of tiles you would need to purchase to cover the floor. Seems easy enough. So we need to figure out what is the area of one of the tiles. And then we're going to divide 120 by that to figure out, well, actually, I guess technically we need to also make sure that our units are the same, right? If this is in feet and this is in inches, that might mess us up if we're not careful. So the area of a hexagon can be found using the formula 1/2 PA. In this case, we know that one of the sides of the hexagon is 10 inches, which would be how many feet? Right, if we do 10 divided by 12, that gives us 0.833 repeating feet. So if you wanted to go ahead and get rid of the inches here so we don't mess this up later, we could find this as a decimal, or we could leave it alone and divide later. It's up to you. You know, live your life. Do whatever you want to do. But I'm going to go ahead and convert 0.83 repeating feet. And we know that to find the area, we need to know what is the apothem. And to do that, we need to know, what's going on with these angles. If we draw in the radii in this problem, connect from the vertex to the center, what kind of triangle do we get? Right, so we've done a few examples this week with hexagons, and if you recall, the center angle for that is always 60, which means that these triangles that we make are always going to be equilateral. Right? And so this is 10, and this is also 10. This is also 10 over here. And we've come up with this right triangle. If we just look at half of it, it looks something like this. Zoom. So this is 10. This would be 5 if we're just looking at half. Oh, and I forgot that I converted that to feet. So 10 inches is the same thing as 0.83 repeating feet. And 5 inches would be 0.416 repeating feet. 0.416 repeating feet. We need to know what this is. All right, so that's 60. This is 30. This side is our 2x side. This side is our 1x side. And this side is our x root 3 side. This is a special right triangle. Okay, so if this is our 1x side, then this side has to be 0.416 repeating root 3 feet. That's our apothem. And our perimeter would be, there are 6 sides, and each one of them is the 0.83 repeating, which comes out to be, hey, 5. It's a nice whole number. Okay, so we plug those into our formula. 1/2 5 feet times the apothem, which is 0.416 root 3. That's such an ugly number. Feet. So 5 times 1/2 times 0.416666 repeating, and then times root 3. Since it's already an ugly decimal, I guess there's no point in trying to separate it. And that comes out to be an area of 1.804 feet squared. Okay. So we've got to cover 120 square feet with tiles, right? So if each tile is this big, we don't know how many tiles we need, right? So we're just going to divide 120 by 1.804. And on the paper, we have a tendency to round answers, right? Because we don't want to write out all the decimals, but the calculator doesn't care how many decimals there are. So I want to divide by the whole amount just to get a better approximation. So I'm going to do 120 divided by the whole decimal without any rounding, which tells us we need about 66.5 tiles. So we need 66.5 tiles. If you've ever been to a store, they're probably not going to sell you half a tile, right? So we're going to round that up and say we need 67 tiles. And then we'll just have to cut it in half ourselves. Although, if you've ever built or tried to put in things that are this shaped, it's probably not going to be just one tile that you're going to have to cut in half. You're probably going to have to cut several in half, so you'd actually need a bit more than this, which is kind of what this last sentence is talking about. A local contractor, aka your dad, recommends that you buy 20% more tiles than you actually calculate. The reason you do 20% more is because tiles can break. That's one option. And also, especially when you're buying tiles that are not square shaped, they don't obviously line up with walls very well. You may have to cut more than you actually thought you would need to fit the area. So if we buy 20% more, we would take the 67 tiles that we're going to buy already and multiply by 1.2. The one part here is the 100% that you already need. We already need 67. And then we also want to add 0.2, 20% onto that. So 67 times 1.2 is 80.4. Which we would really need that to be 81. So we're buying 20% more than we need. We probably should buy 81 tiles. And we'll just hope that that works out pretty well for us. Alright guys, we got one more video this week. I'll see y'all tomorrow. Have a great one. Good luck on the Ames quiz.